Okay. So, hey guys. Hello, my name is Ondřej Mertes, and I'm sorry that I'm not speaking in front of you, but because of some cabling issues, I have to stand here near the projector. Okay, so how do I introduce PHPStan? In PHP, you have to execute the code to find out if it has any errors. So, for example, if you are developing some e-commerce platform and there's an error in the third step of the checkout process, someone has to get himself there to execute that code, and you can find out that you have an error in the checkout process so far. And if you use a compiled language, so who has some experience with compiled languages like C# or Java? Okay, few people. So compiled languages, they can tell about a lot of errors during compile time. So this wouldn't happen to you in a compiled language, because the compiler wouldn't let you to run your application if you would have any error anywhere in the code base, like calling an unknown method or accessing undefined variable, etc. But in PHP, you have to execute the code to find that you have such error there. But I realized that I can give PHP most of the benefits of compiled languages, and that's how I create PHPStan. But first, I would like to show you how to get the most out of PHPStan. So I would like to start with a little introduction to how to structure code. So not all code in your applications is created equal in importance and in error rates, because I personally differentiate between business logic and between wiring. And I suspect most applications, most code bases in the real world consist mostly of wiring. So what is business logic? Business logic is everything what we are paid to do. So it means that business logic represents value constraints. It represents validation, filtering, sorting of data, transitioning between states, calculations, rounding numbers. And anytime you see a mathematical operation or mathematical operator, you should write tests. And you should write tests for all business logic, because it's really important to get the business logic right. And on the other hand, wiring is everything else. It's boilerplate. It's your controllers, it's your facades, it's accepting values and passing parameters elsewhere to your model or to your templates. Wiring is getters, setters, assigning to properties. And as your architecture gets more complex, the more wiring you will write in your application. And but it's important to have wiring, because complex architecture will allow you to call, for example, the same business logic from two places. So you really need to have some. But wiring is really boring to test. Who writes tests for getters and setters? Like not a lot of you. And do you like it? No. Okay. So maybe today I will show you that you don't have to write tests for getters and setters, but use PHPStan instead. So wiring also means that it's testable. Wiring is testable only with slow, brittle, easy to break integration tests, which I really don't like. Because if you really want to test wiring, you have to connect to external services. You have to connect to a database. It's not really easy to test in a unit way. And writing unit tests for your wiring means a lot of mocking, and mocking is basically lying to your code. And every time you see this, you should evaluate if your tests actually bring any value to the table. So if your tests fail because of an actual bug, that's fine. That's a good test. But if your tests fail because they are just not up to date with how the application should actually work, that's a bad test. You should delete that test or repair it. So what I advise to use instead of tests for wiring, I advise you to use strong typing, and that's how you get the most out of PHPStan is strong types. So I would like to show you how strong typed code doesn't look like. So this is actually stringly typed code, and with stringly typed code, everything in your application is a primitive value. It's a string, it's an integer, which doesn't inform you what you can do with such a value. So this is an anti-pattern I see quite often, and it doesn't have any advantage. Why should a directory would be a string? Why should email would be a string? Even sometimes I see a date as a string. It doesn't limit anything what I can do with the value. So instead of passing strings everywhere, I recommend you to use types. So we can have a special type for email, for directory, for everything. So what it means to use types? It means to take advantage of most precise and accurate objects for this purpose. So there is a lot to gain. There's a lot of advantages if you require and pass objects everywhere. And these are three separate advantages. First, you should have consistent creation of such an object. You should only allow email object to be created if you have a valid email. Otherwise, it should throw an exception. Also, if you require types as your function arguments, you also say what can be passed, and only that value can be passed to the function. And last but not least, if you pass object somewhere, you know everything you can do, what you can do with it by looking at its methods. So you can get a lot of value if you pass objects instead of primitive values. And it also applies to documenting return types, as we can see on the last line. Okay, another example of stringly typed code is this. It's referencing magic strings everywhere. So if you see a line like this, it also doesn't inform me what gets returned from the get method. The argument passed to the get method doesn't actually say what can be called on returned value from such a method. So every time you reference a magic string, you should stop and think about how to do this better. And also with this code, you can find out in real time that this service doesn't exist and your code is again broken. So how to solve this in a strong type way is to use good old dependency injection and pass your services. The best way to pass services to a class is through a constructor, and you can type hint everything along the way. So who uses Symfony? So you probably know that this is not the most popular approach, but I also see a lot of value in using dependency injection in Symfony controllers because of these reasons. You know that everything is strongly typed here, and you won't get surprised in runtime that something doesn't work. And you also get auto-completion by the IDE, so we know what's in the full service property. Another nasty thing I see in the wild is overusing arrays. So as soon as possible, your HTTP request is incoming to your application. You should validate that it has everything it should have, and you should create nice, consistent objects based on the HTTP request. So it basically means getting all those $post values and create some nice objects that represent the data and pass them further in your application. So with well-defined type hints, there's not a bad way how to call a method, because the type system will tell you that you are doing something wrong. But if you are requiring and passing arrays everywhere, you can miss a key and the code will break. And also with the arrays, you don't actually know what's in those keys, so we actually don't know what's in values name, index. One use case where arrays are okay is when you use them as collection. So if all elements of an array are a single type, that's fine by me. because that just tells us that if we are passing an array to a for each, so we can be sure what's in the for each value variable. Another anti-pattern I see in the wild is when we write a function or a method and we actually promise that I can handle anything, that the method accepts multiple types. And I really don't like this code because it means that there will be an if condition in the method. And if condition means that you have more branches to test and something can go wrong more easily. And also you cannot define this with a native type hint, so you have to check for yourself if it's a valid type in this parameter. So when you see a code like this, I recommend you to change it to 2 different methods, each with a specific single type hint, and this guarantees you that you will call the correct method from each place. If I have an array, I have to call foo, and if I have a string, I have to call bar. So there are less things that can go wrong with this approach. And the same applies to return types. You should always use a single concrete return type instead of I can return either string or either array, depends on I don't know what. So it's better to promise in advance that the method can return only string, and if you have to return something else, use a different method for that. Another anti-pattern I don't like to see very much are Boolean parameters. So it's a similar thing to the previous one. If I have a Boolean parameter in a method, it means that I have to write an if, and I have to write two different tests to cover everything. And the calls to methods with Boolean parameters look like this, and it's pretty mysterious what the parameter means. So if I call it true, I really want to do something, and if I call it false, I'm not quite sure. I don't know what does mean it to pass a Boolean parameter. So it looks quite mysterious, and the correct approach is again separating these methods to two different ones, and call each method from the place where depending on what you want to happen. And last anti-pattern I would like to show today are nullable parameters. So when I see this, it usually is true that only some combinations of those nullable parameters are valid. So for example, the first 3 parameters must always have to be not null together, or the last 3 parameters have to be not null together. But we cannot read this from the function definition. We have to look at the code itself. So again, PHPStan cannot help you with code like this. So I recommend you to separate those methods into multiple ones, where the parameters, the tuples, are accepted together and they are all required. So you should always be able to refactor the code to have everything required in those methods. Okay, so if you let types spread out through your application, they make it much more reliable, because everything is checked and is type solid. So when you accept an HTTP request, the first arrow is weak, because actually the nature of HTTP protocol is weak. Everything is a string, and we have to modify those types when they come to our application. But everything after the first processing should be strong solid types. And types are also the reason why I like to use an ORM like Doctrine. Who uses Doctrine or similar ORM? Because ORM enable you to represent and manipulate data from relational database using nice consistent objects in an application. So that's really nice. So you can do that without an ORM, but you have to basically write your own ORM to do it. So I recommend using some already implemented solution like Doctrine or something else. Okay, so that's an introduction. And finally we can dive into PHPStan. So PHPStan is a static analyzer. It can find errors in your code without actually executing it, only by parsing and inspecting your source code. And it can tell you whether you are calling an undefined method, passing compatible types, that you are returning what you promised, etc. It brings PHP closer to compiled languages, because compiled languages can also find these issues before you are running your application. And I hope that everyone uses Composer, and PHP works best installed locally into the project, but you can use it globally installed in your system as well. But installing it locally means that every single member of your team is on the same version, and that's much better. So this is how PHPStan looks like in action. It's a little video. So you tell PHPStan which directories it should scan as command line arguments, and it will output found errors, and it scans the code base really fast. For example, at our company it can scan a code base of 600,000 lines in under a minute, so it's really fast. It's much faster than if you would have to write tests for everything. So this is how it looks like in action. Okay, so I hope that everybody saw the video. And when you run it for the first time, there are some hurdles that you can encounter. So for example, you can encounter parser errors in your own code base, because if you are not using any linter or static analyzer, you will accumulate files with parser errors and fatal errors over the years as you are working on your application, and you can find files like that pretty easily if you don't have 100% coverage, because nobody has. And also you can find some misconfigured autoloading, because if you are using PSR4, that requires you to have a file name and a namespace match. You can find that actually some files do not adhere to your configuration, for example are named in the wrong way or have a bad namespace, and PHPStan will tell you about all of them. Okay, so different PHP projects are autoloaded differently. So if you are using Composer for autoloading, I have good news for you. It works out of the box, because PHPStan can auto-discover the Composer autoloader and use it. But if you have custom autoloading, PHPStan needs some configuration in order to work and to load class reflections of your classes. So this is how you can configure your autoloader. PHPStan uses neon format, which you shouldn't be confused by, because it's basically YAML. But I use neon because the underlying core code uses some dependency injection container, and right now if you want to configure PHPStan, you're actually directly manipulating the dependency injection container by writing neon files. But you shouldn't get confused by this, because it's basically YAML and the parameters that you can pass out are all documented. So if you need to scan some directories for your classes, you can use the outload directories key. And if you use some functions, namespace functions or global functions in your code, these aren't actually autoloaded by PHP, because PHP doesn't support autoloading functions, but you have to list all your files with your functions in the autoload files list. Okay. Another thing you have to know about are levels. So when I started first to develop PHPStan, to create PHPStan, I implemented a specific check and merged it to master to our build at our company. And this is a progressive introduction of more capabilities, and it was really worth it, because I implemented the check, we started to using it, and after a few weeks, when I had some free time, I implemented another check, we also started using it, etc. So this is a progressive introduction, one rule at a time, and it went pretty smoothly. And right now, PHPStan is pretty capable, it can find a lot of errors, and I don't want to discourage you that when you run it, I can find thousands of errors in your application, which is really discouraging. So that's why I introduced levels, and if you run PHPStan for the first time, it just runs on the level 0 and finds only basic stuff that is wrong for real. It doesn't find any false negatives. And you can fix those errors, start using PHPStan, and if you have time, you can increase the level and continue fixing issues in your application. So this will probably surprise you, but PHP does not complain if you use an undefined class in these code samples. If you have an undefined class in instance of or in catch, or you are referencing a class name, or you have a type hint, PHP doesn't complain if those classes actually doesn't exist. So you can write anything there, and it's basically that code, or it crashes. So, but PHPStan will tell you about those issues, which is good because you can fix them. On level 0, another thing I do is reporting accessing undefined constants, undefined properties, and undefined methods, but only those which are called statically and which are called all this, because only in those cases I can be sure about what's the type. So statically it's quite obvious what's the type, and on this I also know the type. And I check only number of arguments you pass to methods and functions. I don't check types. So I can tell you, PHPStan can tell you if you are passing more arguments that they are valid, but I won't tell you about types because that would result in a lot of errors in existing applications. And if you are using some magic in your applications, like __ call or get or set, so which can enable you to define methods which aren't actually methods in your classes, but are defined on the fly. So PHPStan can work with them, and you have to write something called class reflection extension and define those methods and properties for the purpose of static analysis. So you can tell which types those properties are and which methods are defined, etc. And you can use any logic you want. So for example, if you are accessing a property, but actually you are forwarding that call to some method that has the same name or some generated method name, you can write a class reflection extension to have those properties defined and known to the static analyzer. Another thing I report on level 0 are unused constructor parameters. So I don't report unused parameters in regular class methods, because they might be there because of an interface or for a different reason, like generating links, or because you are extending a class that has that parameter but you don't have to have it. But in case of constructors, I think it's always a mistake if you have an unused parameter. So it means that you can either delete it, or you probably forgot to assign it to a property. So you can fix your code either way, either delete it or either use it. And it's the same situation with unused anonymous function uses. So you also have to use it, or you can delete it. Another check that I report on level 0 are placeholders and arguments mismatch in functions like scanf, sprintf, printf, because I can check in a static way that in the format string, if it's a literal string, if it's not a variable, because I don't know which string is in the variable, but if you write your code like this, I can tell you that you are expecting, based on the number of placeholders, you are expecting 2 values, but a different number of values is passed to the call. And maybe you are not using a sprintf functions, you are maybe concatenating strings manually, but I strongly recommend using these functions because it leads to nicer code and you have some formatting options, and it's much more nicer to concatenate some values intertwined with spaces. It's better to use these functions. And one maybe pretty controversial rule is that I require calling parent constructor, because I think that calling parent constructor when extending a class is important for consistency and encapsulation of the parent object. Because extending a class is not only is only one way how to use it. Another way how to use it is to instantiate a class, and it wouldn't occur to you to avoid calling its constructor when you are instantiating a class. But we usually do that for when we are extending a class. So I think it's important to have it consistent by calling parent constructor. And when you don't agree with me on some rules, you can use ignore messages, and you can define some regular expressions for errors that can be ignored in the analysis. So it's pretty okay to ignore some messages. We ignore over 40 errors in our largest code base, and the reasons to ignore some errors is that the application is waiting to be refactored, but we wanted to use it. We want to use a higher level, so it can show us some specific error that's not easy to fix in our application. So we can ignore it this way. Another use case is when we are waiting for an extension, for a classification extension to be written. And last but not least, we can ignore messages that are a mistake of PHPStan, that represent some bugs in PHPStan, and we are waiting for a new version to be released with those bugs fixed. Okay, so don't be afraid to ignore some messages. It's quite fine. Okay, so that was all level 0, and we are getting to level 1. You can run different levels by passing --level or shortcut -l to PHPStan executable. And on level 1, we are checking undefined variables. So if there's a possibility that some variable isn't defined, like in this case, because it's defined only in the if condition, PHPStan can report that. And you wouldn't believe how many ways are there in PHP to define a variable. So I think I know about most of them, and one of the most mysterious one is when we are using function fopen to download some URL, and in this case a variable called HTTP response headers is created right after the fopen call, and PHPStan has to account for that in order to work with the real code. So there's a lot of cases how variables are defined, and PHPStan is quite smart and doesn't report you this case. So if there's a variable defined if an if branch and other branches are terminated before we can get to the next line, so in this case everything is fine. PHP doesn't report that X is undefined because it's not possible to reach that line of code without defining the variable. Okay, that's level 1. It can surface quite a lot of errors in your application, like in cases when you are relying on that, for example, for loop or for each loop is at least executed once, and PHPStan can surface those errors to you. Okay, level 2. So level 2 does actually everything that level 0 does, but not only on $days and static calls. So on this level we are actually starting to read PHP doc information, PHP doc documentation, and on this level it's possible that reported errors are not actually errors, but they are only documentation issues. So if you are lying in your property documentation block, PHPStan will tell you that and you should fix your documentation. So we can also use PHP doc for some advanced type specifications like this one. So if we want to tell PHPStan or IDE or developer what's in an array, we can use this notation, and PHPStan will know that if we are accessing a single item of the array or we are passing the array to the for each, what the resulting variables will contain. Okay, and in case of there's a documentation missing or PHPStan isn't sure what's in a variable, I call it mixed type and nothing is checked on mixed. If there's mixed type in your code base, I stop any checks and I don't report any error on in such case. So if you are calling an undocumented function or accessing an undocumented property, I just tell PHPStan that it's mixed and that's all. So there are cases of functions that cannot be documented properly in PHP doc because their return types are dependent on what we pass to the function. They are dependent on input to the function. So for example, in the first line we can be sure that the object returned by the getBy type is of type foo. That's the same in the second case. If we are asking the entity manager to return an article, it will return an article. In the third line it's a little bit different because we are returning the same type as is passed to the method, and in the last line we actually cannot be sure about the type, but there can also be implemented an extension that will look into the container and will tell PHPStan of which type the requested service is. Okay, so you can write not only classification extensions for magic properties and methods, but also dynamic return type extensions for these special cases. Okay, level 3. So on level 3 we are checking if a wrong type is assigned to a property. So if we are expecting that property is of type integer and we pass string there, PHPStan reports an error. And also, if we are promising to return string from a method and something else is returned, PHPStan also reports an error. Okay, that's level 3 that can surface also a lot of issues. And we are getting to level 4. It's important to note that level 4 makes sense to use if you are on PHP 7 and you use scalar type hints, and you will see why. So first rule on level 4 is useless casting. So if we already have a string and we try to cast it as a string, it doesn't make sense, and PHPStan will tell you about it, that you can remove the parenthesis string cast from the line with echo. And it's important to have scalar type hints from PHP 7 because when you turn on level 4, PHPStan will also report that you can remove string from this line, but it isn't quite true because the string is only in the documentation, but actually anything else can be returned, can be passed to the function, and by removing the string cast we could break some code that's calling this function and doesn't adhere to the documentation or pass something else to the method. So in this case the cast isn't actually useless. So be careful with level 4. And on level 4 it's also checked whether you are who uses two equal signs and who uses two equal signs to compare, and everyone else uses three equal signs. Okay, cool. So in case of 3 equal signs of strict comparison, the if condition is that it cannot be true anytime. It cannot be true if we are comparing different types. So PHPStan will tell you, and you wouldn't believe how many lines like this it found in our code base. Quite a lot. Okay. But it's also important to have native type hints instead of PHP docs, because in case of PHP docs the if condition can possibly be sometimes executed if someone doesn't adhere to what they can pass to the method. Okay, the last 3 levels are 5, 6, 7, and some of these features are already in the last stable version, but they are marked as experimental because they are really hard to get right. And you can look forward to all those levels in the next stable version, which is 0.7, and I hope to release it in a few weeks. So until now, PHPStan only checked numbers of arguments passed to function and methods, but on level 5, as you can see in the right corner, it's also checking types passed to function and methods. So if we want a string and we are passing an integer, it will tell you about it, and it will of course show a lot of errors in your existing code. And level 6 is about union types. So although I discourage passing multiple types to a method, as I said earlier, it's an anti-pattern, but PHPStan is about checking real-world code that perhaps looks like this. So on level 6, if you have a union type that consists of multiple types and you pass something else to the method that isn't compatible with either of the types, PHPStan reports that as an error. So when we are expecting foo or bar and we pass something else that isn't a child or isn't compatible in any way with foo or bar, PHPStan reports it as an error. And we can have vice versa situation when we are accepting only a single type, but we have a value that consists of multiple types. So if some variable can consist of an integer or a string, and we pass it to a function that accepts only integer, it can result in a type error because it's possible that in the variable is a string. So these are the checks from level 6. And level 7 is pretty strict because it looks for possible nullables. You can recognize the question mark operator from PHP 7.1, and it's possible that $bar is either null or either bar. So it's not safe to call a method on a bar because it can be nullable and it can result to calling a method on a null error, which we are all familiar with. And level 7 will require you to write code in this way. So if we want to be sure that we do not have any type error in our application, we have to check that variable is not null, and then we can safely call a method on it. Okay, so this was a summary of all features available in PHPStan, but I have a few more slides. And sometimes people ask me about why they should use PHPStan if all those features that I just showed are possible to be checked by PHPStorm. So that's true, but you have to rely, in case of PHPStorm, you have to rely on each of your developers to have it configured in the same way, and also that they use the same IDE, which shouldn't be a requirement. Someone prefers different editors. And it's also easy to overlook when PHPStorm underlines some error for you, but PHPStan is meant to be used in continuous integration environment like Travis. So we can check our code using PHPStorm locally when you write the code, but you can be sure that you won't have any errors in it only if you run it through the continuous integration server, which is the case where PHPStan really shines. And also, it's really interesting that PHPStan is more strict. So PHPStorm actually looks at what's actually assigned to a property. So it doesn't look at the documentation block. So if we have a property that should contain string, but we assign an integer to it, PHPStorm thinks that it should be an integer. But PHPStan really requires you to adhere to your documentation. So it will require for the property to match its documentation block. Okay. So what you can also do is that you can write your own rules. So it's pretty easy to write your own rules and check something that isn't in PHPStan by default. So because you have abstract syntax tree available, it's pretty easy to write your own rules and inspect your code and write your own checks. So you can, for example, write a rule that checks that if we are calling some specific methods, like methods that are marked as deprecated, or if you are really into exceptions, you can write a check that looks for checked exceptions. So you can check that if you are calling a method that has at throws documentation block, so you can require the caller to either catch this exception or also to write it to your throws block. So and you can write anything you want. So maybe someone already tried to write rules in Code Sniffer. You tried to write rules in Code Sniffer. So you probably know that it's pretty difficult because the only thing you have available are tokens. You have, for example, the object operator, and then you have token string, and you have to figure out yourself whether it's a call to a method or to a property or something else. And it's pretty tedious, it's pretty difficult. But with PHPStan, you already have this available thanks to abstract syntax tree that converts your code from strings to a nice tree of objects, thanks to PHP parser. Okay, so what I can promise for the future is the release of 0.7, and I have a backlog of ideas what I want to do with PHPStan. I have a year-long backlog of ideas. So we will release 0.7 with levels 5, 6, 7, and the next points aren't actually going to be in 0.7, it's just ideas what can be done in PHPStan better. So right now you can ignore errors only globally with regular expressions, but I want you to enable also local ignoring. So if you just want to ignore one specific line, one specific issue, you can ignore it locally with some annotations like we are used to, for example, from JavaScript, from slin. Also, I have some ideas how to make the analysis even faster, so that it can look at Git history and it can look for analysis of change files only. But it's not as easy as it sounds, because I can't analyze only change files, but I also have to analyze its dependencies. So if we change one file, we can actually break a different file that wasn't changed, so it's not that easy. And I would also like to enable configuration for third-party documentation defects, because right now, because PHPStan reads documentation of all used source code. So if some library lies about what it returns, right now you have to fork it, or you have to extend the class and use the extended class, but you will be able to configure third-party code through PHPStan configuration. And I have a lot more ideas that we don't have time right now for. And last thing I want to mention is that I would love to work on PHPStan full-time. I really like it, working on it, and I have a lot of ideas how to make it even better. And I think there's a lot of value in it, because PHPStan is already saving a lot of money for a lot of companies. You don't have to write so many tests. You just have to write and use strong types. And PHPStan saves money because it prevents errors reaching your production if you run it in your continuous integration server. So I really want to work on it more, and I am accepting monthly donations through Patreon. And right now I have 19 supporters that sent me $88 per month, which is really nice, but I would like to work on it more, so I need more money. Okay, so that's all. PHPStan currently has over 1700 stars on GitHub, so you can also give it a star, and you can try it out if you want to, if you like it. And you can also follow me on Twitter. I try to write, I'm Czech, I'm from Prague, but I try to write in English, because thanks to PHPStan I already have international audience, so I try to tweet in English. Okay, thank you.
Thank you, Andre. So we will have a break of 10 minutes.